Next up, we have Bill Snow from UltraDNS, who tells us that zone update performance can be an important metric to pay attention to, and moreover, what he has learned from paying attention.
Hi, I'm Bill from DigiCert UltraDNS. So yeah, I'm just going to talk about zone transfer performance. Something that, but what about zone transfer performance? It's something that I care about because I've been working on projects with zone transfer performance for some time. There are some data distribution choices that you can make. I think it seems to me that the de facto choice for a zone globally distributed authoritative zone transfer or nameserver system, if you have data coming from a relational database, maybe they're running an API like a managed DNS system, the de facto choice might be to do some sort of database replication. But we considered how to do that with zone transfers. I think it's worth considering. We're all DNS people. This is the original, eventually consistent protocol, so it's worth considering. But how do we test that for capacity? It's kind of complicated because there is this state machine. I'm sort of getting ahead, I guess. The database replication thing I wanted to point out also has a couple of issues with it, notably the head of line problem. Also the scaling of database systems can be a challenge depending on how you look at it. If you have a zone transfer or a DNS system based on zone transfers, we can transfer all the zones independently, so we don't suffer some of those issues. When we look at a zone transfer system and what to test, I'm looking at specifically a globally distributed nameserver system. It kind of similar to the description in Benjamin's presentation there. We have a tier in the middle. The blue lines there have zone transfers coming in and out. So there's some sort of source of truth that's outside. It could be another primary zone transfer system or nameserver systems doing zone transfers in. It could be a relational database and you're translating to DNS, but it has to come into this distribution layer and then out to the globally distributed system. We're looking to do that in a number of seconds. Your SLAs or your performance may vary depending on where you are in the world. But this blue section here is primarily what I'm talking about testing. So how are we going to test that exactly? How do we do an apples-to-apples comparison? How do we do, what kinds of things can we look at? In particular, normally when we're testing name servers, we look at QPS. Again, previous presentation, lots of stuff about QPS. How are we getting things to run as fast as possible? But it's always a single, simple transaction. As Mr. Spacek showed in the last OARC, there's a state machine involved in zone transfer testing, which complicates things. So we can satisfy ourselves with cold start time, which is pretty good. You take a empty catalog, you start up the name server and download all the zones as fast as you possibly can, and measure the time it takes to do all that stuff. It's a great benchmark, but it's not exactly the same as what is our capacity for updates. How fast can we do updates across this whole state machine? So there's a limit there. So somebody else must do this, right? Like state machines are not unheard of. Of course they do. The web app people do it. So if you have a web app with a bunch of components behind it, maybe you have a queue, maybe you have databases, whatever you have. There's a complicated transaction where somebody has to log in or whatever. The terms that we use for that are more about concurrency. So how many transactions can you have going at the same time rather than QPS, which we normally do in DNS. So maybe this is something we can consider for zone transfers. How many transactions can we have concurrently? So I set up this little test. I created a test server, which is basically generating traffic through notifies, just sends a bunch of notifies. And something like an echo server, which is going to also notify those to the target, running some nameserver software, which then does also notifies back to the original test server. What this allows us to do is send out a notify, mark the time, and measure that time all the way till the end of the last zone transfer. So there's a zone transfer in from the echo server and back out to the target server. So what is exactly is this echo server? It's not exactly an echo server, but it's a simple, very, very simple name server that's just going to always answer with new data. So I did this based on a millisecond serial number. So it basically always answers with new data. I had to build in a zone template where there are records with host names named after the millisecond timestamp, so it's always able to do AXFRs, it's always able to do IXFRs, and SOA responses. So that's kind of what the echo server does. The target host itself, I tried this with bind, not, and NSD. I also tried it with PowerDNS with a Postgres backend. That's going to obviously behave quite a bit differently, and it's kind of weird to have a zone transfer in and out on a PowerDNS server, but I like the software. I've used it for a bunch of stuff, and it's pretty convenient. So yeah, so the test itself does zone transfers in and out, and it kind of goes around the circle. So obviously I had to benchmark this, make sure that it was sane. I first used the startup test. So that's what you're looking at there. Looks generally pretty sane. It shows that it gets slower as the catalog gets bigger. The x-axis there, I don't know if you can read it, but the x-axis catalog size. The rest of the charts you're going to see are all on a fixed catalog size, a small catalog of 10,000 zones. So I also had to benchmark the echo server itself just to make sure this wasn't getting in the way. This has to have greater performance than the rest of them. And it does. It travels, it's pretty linearly up to a bunch of concurrent transactions. All the rest of these charts are all number of concurrent transactions along the x-axis. So that seemed to be pretty sane. And finally, we see some test results. So this is actually running a bunch of queries, and what does it look like? Is it sane? Obviously, PowerDNS, that larger, higher line, it's doing a database SQL transaction for every query, so it's higher. That's what's expected. As you get more concurrent transactions, some of the name servers are a bit slower. Not an NSD, obviously, perform pretty quickly. We're familiar with those sorts of results. So this is pretty sane, but what you're looking at here is actually just the time to do the zone transfer itself, the final zone transfer from the target server back to the test server. So that's less interesting than this thing, which is the actual result of timing from the initial notify back to the second zone transfer back to the test server. So here we see something, more valid performance results. It seems like the thing is working. It spikes up after about 75 on my installation. This isn't like a super tuned thing. I'm not looking at absolute numbers. I'm looking at relative numbers here, really. But bind and PowerDNS kind of spike up. The others go pretty steady for a while. But we are noticing a difference in performance in the average time to transfer as we ramp up the concurrent transactions. So that seems pretty sane, kind of interesting. One thing that's very worth considering is the number of transactions per notify. So I'm generating the traffic with notifies, but measuring that up to the time when the last transfer happens. So you would expect, there's kind of a horizontal line in the middle there. You would expect to get 100% of them back, and maybe they would fall off after a while, which we do see with PowerDNS. So overload the thing, and it is unable to keep up with the transfers. But we also see a giant lump in the middle. Unfortunately, this is the refresh timer. I set a very long refresh time on the zones, so I was hoping that I wouldn't really get that. But what you find in a bunch of the data is, of course, these things are randomized. So you've got a lump of data where every SOA query obviously gets new data because of the way the echo server is set up. So there's a lump in traffic there. It's a little bit hard to compare, but that's where that is. I think it's important to talk about losing transfers because one of the metrics, of course, is time, as I showed. But losing a notify and losing a transfer are kind of two different things. If we're unable to complete a zone transfer, then that's something that can be retried. But if we lose a notify, which is something that definitely happens, then you have to fall back to refresh time. So there's this balance in a global distributed installation between SOA query traffic and the length of the refresh time. In a globally distributed environment, you probably want redundant notifies. I didn't cover that in any of these tests, but that's something that's kind of important, and it's a clear distinction, which leads to some extra work they won't really talk about. This is an interesting slide. Across the bottom, again, is the concurrency. The y-axis is the number of transfers per second. And there's an interesting behavior here because 3 out of 4 of the name servers, you see that diagonal line, they're matching the number of queries to the concurrency. So what's actually happening is different behavior in different name servers. I cut out all the TCP dump stuff. from the slides, but what we see here is different timing. 3 out of 4 of the name servers are waiting at some point in the process, some point in the state machine, with some sort of a delay. It's not exactly a rate limit, but PowerDNS, for example, will receive and notify and wait for 1,000 milliseconds before it does the zone transfer. NSD does the zone transfer right away, but waits for 1,000 milliseconds before it sends along the next notify. So you end up with the same performance here, which does limit the ultimate performance. Bind, of course, does it right away. You can see that, so it's set up for sort of an immediate update. So another piece that I did, the same sort of test. You can imagine adding and removing zones from a catalog of 10,000 zones. If you have some sort of big installation, I'm thinking about managed DNS infrastructure because that's kind of what I work on. But you have these large catalogs. You have to add and remove zones. And the performance of that is kind of interesting also. So I'm going to go through this a little bit quickly. But what happens when we remove them? I did the same trick with the Echo server. It's able to add in and do IXFRs and AXFRs. And what we end up seeing here is a similar kind of chart at a smaller scale. Of course, there's more going on because when you add a zone, you have to query that one. So there's more activity. And what we end up with is similar chart with smaller numbers. So that seems like a sane way to check that also. Again, it's concurrent transactions adding and removing zones. Yeah, so on the basis of time here, I'm going to skip through these pretty quickly. But again, you show similar performance. They're doing similar things. The timeouts still count. And I'd like to kind of talk about some conclusions here. At the beginning, at the outset, I'm talking about comparing this to other ways of moving data around database replication or whatever. Of course, the answer, like everything, is it depends. Installation-specific tuning is very important. But yeah, it seems like zone transfers are an option. There's a bunch of things that I didn't cover. So I would like to get rid of the refresh traffic. So that would make those charts cleaner and be able to deal with it. You'd have to cache the serial numbers in the Echo server or something like that. Multi-primary tests and that idea of redundant notifies. That seems like an important thing to include. Of course, in the globally distributed system, there's a bunch of network delays that kind of change performance. They change how things behave. So I can simulate those. There's lots of other things that we could update. But yeah, that's basically what I've got. So thank you very much. I'm actually early, which I was surprised about, but this was great. I appreciate the opportunity from OARC. So if anybody has any questions.
Do we have any questions? If there are no questions, it's not going to get you your lunch any quicker.
I didn't run long, though, so.
Patrick, I see. I wanted to ask how much you tweaked the defaults for a number of parallel transactions, zone transfers and stuff like that in your test, or were there defaults or some your
defaults for the numbers that I chose in that?
I mean, each implementation has their own limits or number of concurrent zone transfers, serials, or whatnot. So were you using defaults in your tests, or
mostly defaults? It's not very well tuned, so it's just an installation to kind of mostly what I wanted to validate was this concept of using concurrent transactions. But it is spread across all the zones. So the traffic that I'm generating with the notifies, that's all randomly selected zones.
Yeah, okay. I'm asking because, for example, bind has a special limit on number of concurrent transfers to the single IP.
Right.
So even if you spread it across the zones, it will be limited by that particular NOP in the config.
Right.
That's what I'm asking. Okay, thank you.
Yeah. So I did think of that in terms of zone transfers. The slide isn't very descriptive. I apologize.
So, Warren Kumari, Google. I don't actually know what you guys run to answer queries, but how are you currently distributing zones? Like, did you look
inside UltraDNS?
Yeah.
So there's a lot of different ways to do things inside UltraDNS because there's a bunch of different services. So there is some database replication. There's, of course, we have customers who have run their own name servers. So that stuff, for the most part, is done through zone transfers. So there's kind of a bit of everything. Yeah. Of course, they have any different SLAs, and if I've said anything about timing, please don't, hold me to that.
Alison Mankin, Packet Clearinghouse. Thanks for doing this. This is like a really important, interesting, very multifaceted problem for big global footprints. I think it's fair to say that for customers, XFR is the kind of baseline standards, easy thing to do. It'd be nice if you want to follow up with a study of database replication and whether it's for the internal and whether it performs better. And also, it's kind of novel to tell us more about the customer's use of the calendar zones and whether they're scary and dangerous and how, what the limits are. So maybe we could get the limits in place sooner rather than later, because we have a lot of things where we don't discover limits till it's kind of late and we get in trouble. So thank you for
You're talking about the catalog zones?
Catalog zones, I meant, yeah.
Yeah, it's interesting. It seems to me like a great way to group things together, but it's not necessarily the right thing for customers.
It's got a lot of scope, and it's very useful for customers, but we haven't necessarily, it's like all the other things that have like unlimited scope, but what do they mean when we get out there into a big infrastructure? So again, lots of good stuff to chew on here. Thank you.
Thanks so much. Anybody else?
I'm not seeing any more questions, so thank you very, very much.